Encryption in communication. Is it broken? After this video, you may have a few sleepless nights. Welcome. I'm George Krauss, a blockchain inventor, security architect, hard and software designer, and when time allows, a photographer. Start with some basics. In communication, like in many internet-based apps, encryption is a major mechanism to provide security. Other people may still see your data, but with strong encryption, they should not understand the contents of your bits and bytes, which is on the communication lines or on the air. Unfortunately, in practice, there is no such thing as an unbreakable encryption. History tells us that all encryption algorithms were broken sooner or later, and there is no reason why this should be different in the future. Actually, the opposite is true. Why? Here are some reasons. First, mathematical knowledge as well as technology improves faster than ever. With ongoing improving processing power, we can try to decrypt more messages in the same time. As long as this is an evolutionary process with small steps, we may be able to estimate for how long an algorithm with a given key may be secure. But we may make also huge steps from time to time with new inventions based on complete new ideas. This is then more a revolution, no more an evolution. It may then take some time until a new technology is ready, but then it can change everything. We are just now experiencing such a revolution. It is called quantum computing. Besides solving many other problems, quantum computers can be used to factorize large numbers into their components. This means your private keys used for certificates are no longer secure. This has enormous impact on the whole industry. Bitcoin needs completely be rewritten, but it is not yet clear how a new quantum-safe cryptocurrency would look like. Many things we use today are soon obsolete. Here comes the question. Is the encryption you use already broken, and who may listen to your traffic? We don't know. Besides a huge impact from quantum computing, other, more traditional methods are also thinkable. Intelligence organizations sniffing traffic are not new. If someone has broken an encryption, will he tell the public or use this knowledge to its own advantage? A university professor will most likely write a paper, speak at conferences, and tell the world. This may be good for his reputation. An intelligence organization on the other side will most likely use their knowledge to their own advantage and keep very quiet. Collecting information is their job. But what if such an advantage, call it trapdoor, is built into the encryption algorithm already? Again, we don't know. But we learned from Edward Snowden that such things exist. If someone has additional unpublished mathematical knowledge, this may be used to create a trapdoor. Such things may be built into the apps everybody uses every day. Open your eyes. Encryption in your apps does not automatically mean that you are secure. Please be here very critical. The team who programmed your favorite app is definitely excellent in their application field, but are they also encryption experts? More likely not. They use prefabricated libraries and trust them. When then something happens, people like to say it was a computer glitch. But there is no such thing as a computer glitch. Either hardware breaks down, or design and implementation failures were made by humans who created or designed the thing. Now, there is no way to eliminate all risks, but you can minimize them if you follow a few rules. This and the following videos will present a lot of know-how concerning encryption for communication and what you can do. Let's start with a set of rules you should follow when you have really sensitive data and you need to exchange them to a remote partner. Rule number 1. Knowledge is essential. The better you understand these things, the better you can reduce the risk and protect yourself. This means learning and studying different topics. If you have interest in this technology, it is fun and turns out to be easy. You can do it. To assist you, I produce a set of videos covering the different internal aspects of encryption. Rule number 2. Don't rely on the promises from most apps. Many say they are 100% secure. Do not use them for your really sensitive data as long as you do not have strong evidence that they can be trusted. A banking app evaluated by security experts under strict government control. Yes, I use such an app for myself. If someone writes and says 100% secure, don't use it. Rule number 3, trust only yourself. This means you must have control over the essential processes and the involved secret. Don't delegate critical steps to third parties. A digital currency exchange is not the place where your secret keys should be stored. Remember Rule 1 and learn the details. Rule number 4. Use only end-to-end encryption. When you send sensitive information from A to B, then A has to encrypt and B has to decrypt and nobody else in between. An example are home offices. If you use a video app, then there is an app server in between managing the communication to your partner. Such a man in the middle is the ideal location for spying. In a separate video, I will show in detail how such a theoretical attack may work. If you use end-to-end encryption, make sure it is installed very near to your processing endpoint. Anybody in between must see encrypted data and must not have any chance to get hold of the encryption key. Important, use it from a separate source, not from the provider that supplies your communication line. Rule number 5. Use dedicated hardware for encryption. Software in your computer can be manipulated by software. Windows users experience this with every update. Every update changes the software in your computer. In many cases, this involves components of the inner part of the operating system itself. But none of these software updates can change the hardware in your system. Software can just not change the hardware. You need physical access when you want to replace a chip on your motherboard. This provides a huge barrier for such an attack. If you use for your encryption a separate hardware which is not controlled by any third party and which physically cannot be bypassed, then a big step for your security is accomplished. Rule number 6. Separate your sensitive data, business-related, private and sensitive, from other data like web browsing, shopping, and social media. This is a logical consequence of rule number 5 and means often that you use two computers. Example, one for business use and one for private use. I will show in another video how this works with one internet connection and an encryption device which can also separate the two worlds. Let me, in the second part of this video, dive a little bit more into encryption basics. We focus here on fast data encryption as it is used for IP traffic in most of your applications. There are other types of encryption, like public key encryption, which are not covered in this presentation. You will definitely use encryption algorithms already, most likely AES included in apps you use every day. Every encryption algorithm needs a key, which is the secret information the algorithm requires for encryption and decryption. If the algorithm you use is public known like AES, then the only protection comes from your secret key. A key is a long number of digital zeros and ones and should not be able to be guessed. Long means here 256 bits or more. Using a password, which is then converted into a key, may not be the best idea. If the key is not long enough or not from a true random source, it may be possible to try all key values and see if one successfully decrypts your messages. Then your encryption is broken. Trying all possibilities is called a brute force attack. If an algorithm has no other weaknesses known, then statistically a match is found after half the possible keys are tried. This means after 2 to the power of 255 attempts for a 256-bit long key. Still not feasible with today's technology. A 2 to the power of 255 is 5.789, and then move the decimal point 76 positions to the right, a 77-digit long decimal number. So use strong keys, long enough and true random. Now, key management covers the way your keys are handled. This includes how your keys are generated, how the keys are stored, how keys are exchanged, how keys are used inside a product, how key backups are created if required, and how and when keys are erased at the end of their key life. Rule 5 applies also to key management. Key management should be implemented in hardware. Stored keys in the file can be copied and you cannot see it from the original file that it was copied. You cannot copy hardware. You have to manufacture it. So it is a much better control where your keys are. If an enemy can spy out your keys, then you are definitely lost. We all may know some examples of unprofessional key management at some Bitcoin exchanges. When investors give their private key to a third party, which then loses it, breaks down or gets hacked, the money is forever gone. In that field, many mistakes were made and many are also publicly known. The opportunity to make fast money blinds many people. So this is enough for this initial presentation. If you follow Rule 1 to 6 and implement the required steps one after the other, I'm sure you may sleep peaceful. Thank you very much.